So today we're going to talk about the standard form of a linear equation, which is point 2.3 in our notes in our textbook. So today we have three objectives. We'll be able to define the standard form, write the slope-intercept or point-slope form equation into standard form, or write a standard form equation into slope-intercept form. So in other words, we need to be able to go from standard form into the other forms we know, or from the other forms we know into standard form. But before we do that, we first have to define the standard form. Okay. So before we do, let's do a little review. The slope-intercept form, of course, that's easy to use. It gives you the slope and the intercept, and that's y equals mx plus b. The point-slope form is also easy to use. It gives us the point and the slope, and that's y minus y1 equals m times x minus x1. Now we're going to introduce a third form, which is called the standard form. And the standard form, which is also called the general form, is always in the form of ax plus by equals c, where we have the variables, our x and y, on the left side, and our constant term, our number, is on the right side. And in this case, a, b, and c are all integers, and a and b are both not 0. One can be 0, but both of them cannot be. And the advantages of standard form are that it always looks the same, and all the coefficients are integers, so there are no fractions. The disadvantage is you can't tell at a glance information about the graph. So there's no information about slope, intercept, or point. So we said we had three objectives. Our first was to define the standard form. Our second is to take an equation in the other form, slope, intercept, or point slope form, and create it in standard form, or put it in standard form. So let's do that next. And we have two examples. The first is in slope-intercept form, y equals mx plus b. And so we have to follow a four-step procedure. The first is to make sure that all the coefficients are integers. For this one, that's already done. Our coefficient of y is 1, our coefficient of x is 3, and our constant is a 2. So no fractions. We're good. We can move on to the next step, which is to get our variables, our x and our y, on the left side and our constant on the right side. So when we look at this one, we have a variable x on the right side. So if I subtract 3x from the right side, of course if I do it to one side, I have to do it to both. And by subtracting the 3x on the right side, it cancels. So when I'm done, I end up with on the right side 2, because the 3x's cancel, and on the left side y minus 3x. So we're done with step 2. We've now put the constants on the left-hand side. The third step is to always put x first, because we're going to have ax plus by equals c, so x has to come first. So I'm just going to take the y minus 3x and flip that around to be negative 3x plus y equals 2. Okay, so now we're done with that. Now technically, we're done. That is, we've taken it and put it in standard form. Negative 3, 1, and 2, our a, b, and c, are all integers. So we're done. However, by convention, we'd like to make sure that x, our x coefficient, is positive. And currently, it's negative 3. So if I take that negative 3 and take this entire equation and multiply by negative 1, then negative 1 times negative 3, a negative times a negative is going to be a positive, so that'll be positive 3x. A negative times positive y is negative, so that's negative y. And then a negative times a positive 2 is negative 2. And so now we've made x positive, so there's our final answer. 3x minus y equals negative 2. We've taken our original equation and put it in standard form. All right. Let's look at another example. This one is in point slope form, where 2/5 is our slope and 3/4 is our point. But we're going to follow the same four steps. First, we have to have integer coefficients. When I look at this one, when I multiply the 2/5 times the quantity x minus 3, I'm going to end up with some fractions there, 2/5 x and negative 6/5 for a constant. So if I take that whole side and multiply by 5, I will get rid of the fractions there. But of course I can't multiply just one side by 5. I have to multiply both sides by 5. And now by doing that on the right, this 5 is going to cancel with this 5. So we're left with, on the left, 5 times the quantity y minus 4 equals 2 times the quantity x minus 3. I need to distribute my y, so I get 5y minus 20, and distribute my 2, so I get 2x minus 6. And now I have no integer, I have only integer coefficients, so I've finished step 1. Step 2 is to get my variables on the left and my constants on the right. So to get my variable on the left, I have a 2x over on the right. So if I subtract both sides by 2x, those 2x's will cancel. And on the left, I'll have 5y minus 2x minus 20. And on the right, I'll have minus 6, just negative 6. But now I still have the negative 20 or minus 20 on the left, so I need to add 20 to both sides. Now those 20s cancel, getting rid of that constant on the left. And so on the left I have 5y minus 2x equals 14. So we've now isolated the variables on the left-hand side and the constant term on the right side. The third thing we need to do is make sure we put x first. So I'm just going to flip that. I'm going to flip 5y and negative 2x around, so it's negative 2x plus 5y equals 14. And we're done there. So technically, again, this is in standard form, but by convention, we like to make x positive. So if I take this first thing, if I take negative 2x plus 5y, and I flip it around and put the 5y first, I'm sorry, it's the other way around. Sorry, oops, sorry. I'm going to take this whole thing and multiply by negative 1. Sorry. Okay, then my negative times the negative 2x becomes positive 2x. My 5y times negative 1 becomes negative 5y, and my positive 14 times negative 1 becomes negative 14. So we're done with our final step. So here we are in standard form. So our third objective is to write the standard form equation in slope-intercept form. So if we take a standard form equation, can we flip it around and turn it into slope-intercept? So essentially the opposite of what we did with our first example problem. So let's do our third objective here. So here is an equation in standard form, ax plus by equals c, and we're going to take that and we're going to turn it into the slope-intercept form. So there is the equation. The first thing I need to do is to put the y term over on the left. So I currently have that x on the left, so I need to get over the right by if I subtract 3x from my left. Of course, I've got to do it to both sides. So the 3x's cancel, and I'm left with negative 4y on my left and negative 3x minus 2 on my right. So now I've gotten my y term on the left, and the only other thing I need to do is to isolate y. The format is y equals mx plus b, not negative 4y equals something, so I want to get that y isolated. So it's negative 4 times that, so the opposite of that is to divide by negative 4. But of course, if I do that to that term, I need to do it to this term here, to the negative 3x term, and the negative 2 term as well. So the negative 4's cancel, so on the left I have y, that was why I did that. And then a negative 3x over negative 4, a negative over a negative, this becomes positive, so it just becomes 3/4 x. And then negative 2 over negative 4 is a negative over a negative is a positive, and 2/4 reduces down into 1/2. So now here is my y equals mx plus b, so we're done. And again, the advantage of this is now we can see at a glance that my slope, m, is 3/4, and that my y-intercept, b, is 1/2.